And energy. In energy sector also, the chemistry is very much important. Now solar panel लगाओ then because petroleum is also that is also a organic compound. Or the fossil fuel is limited, so that is why we are moving for solar panel. And solar panel is made up of this type of material: one electron acceptor part, one donor part, and the sunlight falls on that one, and electron is ejected, and that becomes the electricity. So this is about some chemical updates, or what is the application of chemistry or chemicals in our day-to-day life. So next, I want to share some of my knowledge or my research field. I work in the surface chemistry. Surface chemistry is a branch of science which deals with many surfactants. So surfactants are amphiphilic compounds. Amphiphilic compounds containing a polar part and a non-polar part. Here, this one is a hydrophobic gel, and this is a hydrophobic gel, hydrophobic head group. So this is water insoluble. This is water soluble part. So when these molecules they are put in water or in non-aqueous solvent, they form different types of self-assembly. Immediately, myself, microemulsion. We'll discuss later on. So these are the different classification of surfactant. We can have non-ionic, ionic, and photonic. These are all non-ionic surfactant. Here, this is the tail part, this is water insoluble part, and this is the polar part. Polar means having more electronegative atoms. These are ionic surfactant. This is anionic. That is negative charge, and the water ionic charge. This is cation. And we can also form amphoteric. That means both positive and negative, both charge will be present in the same molecule. Amphoteric molecule. Deuterionic. Then Gemini means two surfactant attached with spacer. Polar surfactant, two head groups are present, and one thread will be present. Then polymeric surfactant, polymeric surfactant, copolymer. Now, so it is copolymer, blood copolymer. They also can be used as surfactant. They are natural polymers. Here, this is casein, caffeine. They are natural polymer. So the aggregates to form different types of self-assembly. So when the surfactant is put into water, when the concentration is less, this is surfactant monomer. When you increase the surfactant solution in water, then micelle gets formed. And if you put some oil, because oil, pani or oil mix it over. But using surfactant, we can mix up the same phase. Oil को भी हमें solubilize करना by the use of surfactant. So by the formation of oil in water, oil को हम अच्छी oil is in the middle and outside water is present. So that is called oil in water microemulsion. Similarly, when the surfactant is put in some aqueous solvent like organic solvent, then they form reverse micelle. And if you put some water, then you can form water in oil microemulsion. So they can also form monolayer and basic. So that is why this surfactant system, they can, because in our body, living body, the cell wall is made up of fatty layers. So we can mimic those fatty layers, and we can study those activity of the biomolecule in the surfactant system. let us discuss some application of the detergent. What is the cleansing action? This is available in Google. So what happens? Because we can have two types of dart. Water insoluble and water soluble. Water soluble dart can be easily removed by putting in water and some reach level. But water insoluble part that cannot be removed. So if you put some surfactant, this is part adds up like this, then they can form a heavy micelle, and after that this dart is soluble in water and this moves to the water phase, and if you remove this water, you are getting the clean clothes. So this is what application of cleansing action of detergent or surfactant. Surfactant can also be used in the form of nanoparticle because they can compartmentalize. They can compartmentalize ସେମାନେ polar part or non-polar part को अलग अलग करते होते हैं. So that is where they selectively allow some particles to react. So that is where in this nanoparticles can also be formed or in surfactant systems. Either this is one example where gold nanoparticle is formed because what is happening? Because सब कुछ यदि मिसिजिबो, then it becomes a microparticles. And if we are not allowed to mix those particles, then it comes in the nanoform. Then this is one typical effect you must be knowing. এটা দেখি দিব তুমি कौन मान के देखिए ना पानी दे तुम्हारे पदम फूल में पानी नहीं बना बुल दिया ना because that surface when this surface was kept on the microscope it is found that it is having this type of tubules and these are super hydrophobic, that means they do not allow us to touch the water, and this type of things is also present in the body of the parts. तुम्हें देखी थी से पक्षी मान करो पानी देवे समझ किसी ना because water cannot penetrate into their body, so they remain healthy in the rainy season also. So this super hydrophobic effect, this can be used in different purpose. Let's see here. If somebody is being in your on the wall of the or boundary, then if you have painted with this type of super hydrophobic surfactant, then it will affect to that person. So surfactant is having numerous applications I have discussed in micellar catalysis, nanotechnology, detergent chemistry, petroleum chemistry, and phase one management. In that also surfactant is present. So cosmetic, bioremediation is also now is going on. Soil remediation is also going on. So surfactants having numerous applications. So we have used some non-ionic surfactants. This is 280 and this is 300. They are very cheap, and these are the co-surfactant. Co-surfactant means they are also surfactant like, but it is having a small chain. In case of surfactant, the chain is long. Here the chain is short. So this is a surfactant. This is co-surfactant, and kerosene and hexane. This can be used as oil part, and water is the polar part. And this is the you must be having phase diagram पढ़ी हो तो chemistry पे लगी क्या जो chemistry phase diagram है जो phase diagram phase equilibrium. So this is the ternary phase diagram. हमें पढ़े जो two dimensional two component system. This is three component system. One component is emulsifier, water and oil. So this part is 100% your 100% emulsifier, this is 100% water, this is 100% oil. And this is the microemulsion region and this is biophysic region. So in this way, we can form a number of phase diagram. So phase diagram tells about behavior of the surfactant solution. तो आगे सही जगह यूज करी पारबा कि नहीं पारबा सही कंसंट्रेशन में microemulsion form होगा कि नहीं because we are interested in formation of the microemulsion form ହେଲା ନାହିଁ and যদি formula के type of form है then can we have to demarcate those things. This is a trilinear reductant line you see, reductant line you see, three lines are there. This is water in oil microemulsion here because the volume of prime is less, but the water is less. So that is your water inside and oil is outside. This is the bicontinuous zone. Here both oil and water both are present in the same concentration. And when we increase the water concentration, this is called the oil and water microemulsion. So after the formation of phase diagram, we can demarcate the eta oil and water microemulsion होची ना water and oil microemulsion होची ना bicontinuous case bicontinuous BC from bicontinuous two type of microemulsion form होची that can be known from this phase from this conductivity is it conductor versus brine. Again in this phase diagram, this is the microemulsion phase, eta was the microemulsion phase, and this concentration is oil and water, this concentration is bicontinuous, and this concentration is water and oil microemulsion. Again, we have also taken the dynamic light scattering. What is the particle size? Two type of particle size होते because I am telling that this is micro heterogeneous system. This is the water and oil microemulsion. So here this is around 10 nanometer. So when we move from here to here, this is the maximum size, and again size decreases. Oil and water microemulsion में छोड़ के सी हम water and oil में छोड़ के सी bicontinuous था बड़ा particle के सी and it is having different size. So it is having two types of. Here it is, this green one is 100 nanometer. It is 10 nanometer. This is 10 nanometer. This is 100 nanometer. Again this is blue one is. This is again in between 10 to 100. So when we move from here to here, then this is smaller. This is smaller, but this part is bigger particles. So they can have more substance that may be organic or inorganic. And we have investigated this surfactant solution in microscope. Microscope we have this type of particle housing. Okay. And again, why I am doing this one? Because to study the separation, or we want to use those microemulsion for separation purpose. So when this concentration, this is better of this concentration. So when we increase the temperature from 34 to 58 degrees, it becomes 3 phases, and we are getting, and after 27 degrees, it becomes 3 clear phases. That means three microemulsion of different concentration. And we have studied this 3 layer. This one is mostly the non-polar layer, mostly oil layer. This is bicontinuous zone, and this is water-based zone. And to study this one, we have used 3. These are all dye. 3 organic dye. I have synthesized through that nature picture. So you see, the C1 is having one carbon. The chain is having only one carbon. Then in the next carbon, it is the number of carbon is 6, and in the next it is 16. So that means when we moving from C1 to C6 to C16, then we see that the hydrophobicity is increasing. Hydrophobicity what is that? So that is why this is more soluble in the oil part, and that is more soluble in the water part. And also it is seen now here. This is lower layer, this is middle layer, and this is upper layer. Upper layer is only the oil part. There's no is there. So when we study the middle layer and lower layer, we found that the dye having long chain. The dye having long chain, the concentration is less here in the lower layer, but where it is higher. It a green dye. Green dye which is C1,